All right, welcome back to our second lecture video on Chapter 21, Capital Budgeting. In the first lecture video, we kind of just went over an overview of what capital budgeting is, and then we looked at the first primary method in assessing capital budgeting decisions, and that's using the discounted cash flow method, specifically a net present value method to assess whether or not all the cash inflows and outflows associated with a project are going to be positive or not. And as we said, if it is positive, it's a good project to move forward with. If it's negative, it's not a good project. Or if we're comparing two different projects, you would go with the one that has the higher NPV. So in this second lecture, we're going to go over one more method. It's very simple and pretty quick, and it's called the payback method. So this should be a relatively short lecture. So these are our same two projects, Project L and Project S from our prior examples. Both projects have a $100 outlay. Project L, we get $150 cash inflow. Project S, $140 cash inflow. But we see that the larger payments come at the end in Project L, where the larger payments come at the beginning in Project S. And so in the prior lecture, we found that although Project L has a higher amount of cash flow overall, Project S was the preferred project if we were using the discounted cash flow uh, NPV method with a 10% return. And so now we're going to look at these same two projects and use the payback period method. So the payback method, it looks at how long will it or how long will it take to recover our initial investment? So let's look back, and it just says for these projects, we're investing $100. So how many years do we have to go before we at least get our $100 back? So it's pretty simple method, and obviously shorter payback periods are preferred. If you can make an investment and get your money back tomorrow versus make an investment and get your money back in 20 years, obviously we'd prefer to have that shorter investment or get our money back right away. So this just says it's pretty simple if your uniform cash flows. So that's an example. We have a $100 outlay in year one or years two, zero. And then at year one, say it's $20. Year two is $20. Year three is $20. All we'd have to say, if each one of these years is $20, well, our payback period would be our $100 investment over $20 per year, or 5 years, right? So we'd have 20 plus 20 plus 20 plus 20 plus 20, and that would equal 100. So if you have uniform cash flows, which means the same cash inflow every year, it's just our initial investment over the annual cash flows. So that's really simple, but as you can imagine, it's probably pretty rare that most projects would have consistent and exactly even cash flows. So what we do is we really just add cash flows by period until we cover the initial investment. And then we just count the number of periods or years that were included to get over that amount. So let's do a real quick example. Let's go on with our Project L and Project S. So let's do this for Project L. So Project L says we have a $100 outflow. So our cumulative cash at this point is $100 out. At year one, we have $10 in. So now our cumulative outflow is $90. So we've recovered a little bit of that, $10 of our outflow, but not enough. Year two, we get $60. So now we've covered all but $30 of our initial outflow. And then we see that by year three, we'll make $80 more. Well, we only needed to cover $30 more of our initial investment at the end of year two. So we're going to go way above our initial investment by year three. So we know that it's going to be year one and year 2 are going to cover most of it. So we have our first 2 years plus we need $30, but we're going to make 80 in year 3. So it's what we need, our $30, divided by the total amount we're going to make in year 3, $80. So this says we're going to have a full year 1 and 2, plus we're going to need to make it about 0.375 percent, or 37.5%, I guess, the way through year 3 before we cover it, before we completely cover our $100 outflow. Right, so the only tricky thing about doing this year by year is you add it up and you find out, hey, what year will we completely cover our initial investment? In this case, it was at some point during year 3, we were going to completely cover it. So we know we need at least our first 2 years and then some portion of year 3. Well, that's just the amount we need, we have remaining, over the total amount we'll have in year 3, and we'll get a proportion of that year that is going to be required. So for Project L, we'll recover our costs in about 2.4 years. So let's look at Project S. So Project S, same cash outflow, but in year 1, we get this big cash inflow. So at the end of year 1, we only have to cover $30 more. Well, in year 2, we're going to make $50, and that's more than we need. So now we know we only needed a full year 1, and then we needed $30 out of the full $50 that we'll get in year 2. So we'll need the full year 1 and 0.6 of year 2, or 1.6 years total. Again, the only thing that's tricky is just recognizing that at the end of every year, how much do we have left? We have 30 left. Oh, we're going to make 50 in year 2, so we don't need all of year 2. So we know we're going to end some point before the end of year 2. We don't need all of it. So it'll be that 1 year plus some portion of year 2. In this case, it's 0.6 of year 2. So as you can see, it's a pretty simple analysis just to say, hey, how long is it going to take us to recover our initial investment? So there's some strengths and weaknesses to the payback method. The big strengths is it provides an indication of the project's risk. If it's going to take you a very long term or very long time to get your money back, there's a lot more risk. So imagine in project 1, it's going to take you 2 years. In project 2, it's going to take you, let's go crazy, 40 years. Well, it's pretty easy to see which one's more risky, right? Think of how many things that could happen in 40 years that mess up this cash flow and make you lose out on your money and not recover your money. So it's a really good assessment of how risky a project is. And then 2, very easy to calculate, and it's very intuitive to understand. It just lets you know how long is my money going to be out there before I recover my initial investment. The weaknesses of payback method. First one is it ignores the time value of money. As we see in the last example, that all we do is calculate years to recover our investment. We didn't incorporate any form of discounted cash flow or net present value. So that definitely is a weakness, especially if you get into these projects like Project 2 over here, where it's 40 years. At that point, time value of money is going to be extremely important. And then this last point here is probably the most important of why this tool isn't necessarily that would never be the end all be all to some analysis. This is really good at high level saying, hey, is this risky? When will we get our money back? But if you're making a real business decision, you would not stop at the payback method. And here's why. Imagine project 1 had cash outlay of 100, and then in year 1 you got $80 back. In year 2 you got $20 back. In year 3 you got 50. we can see that the payback period for this project would be 2 years, right? We laid out 100, then we got 100 back within year 1 and year 2. So now let's look at project 2. Say we had $100 outflow, then we got $1 in year 1, $1 in year 2, $1 in year 3, $1 in year 4. So look, the payback period is at least 1, 2, 3, 4. It's at least 4 years, so it's 4+ years. But what about in year 5 if we got paid $36 billion, right? Which project would you take? The one that pays you $150 total, or the one that pays you over 36 billion? So even if project 2 took an extra year to pay back your initial $100 investment, if it paid you an extra $36 billion, that's probably going to be the more attractive project. And so that's kind of a ridiculous example, but it just shows that the payback period really isn't a good full analysis. It has some useful information, but because it ignores all the cash flows after that payback period, in this example, you would have been ignoring that $36 billion payment. And so you probably would have made a pretty poor decision had you only went with the payback method. So that's it for this lecture. Uh, so this should be posted on this date, or it's scheduled for this date on our schedule. And so that means coming up really soon, if you're watching this on the scheduled date, hopefully you're watching it a bit before. But I just want to remind everybody that on April 29th, we have a lot due. We have our big group project due. And remember, this should be the best, most professional thing ever. Right? It needs to be a really good professional deliverable. We have our group evals due, and this is the form is on Canvas, and you submit on Canvas, and everybody has to do that. If you don't turn this in, it's a really big deal, and it will hurt your participation grades. And then you also have your homework for this section due. So make sure you get all that in. And if you're watching this, we should be pretty close to wrapping up the semester. Hopefully everything's going great. And hopefully everybody's staying healthy and happy. All right. Thanks a lot, guys. We'll see you in the next one.